Okay, today we're doing 4-4, and this is solving inequalities with multi-step equations. So the purpose of today is to solve inequalities with multi-step equations. A lot of our word problems are multi-step equations, so we're going to work on both the word problems and the actual inequalities, solving them. All right, so when I have something like this, what's the first step we do? Step 1, what do we undo first? Jamie?
I would add 5 to both sides.
Right, we undo our addition and subtraction first. So step 1, we are undoing addition and subtraction first. Okay? And then I end up with 2x less than 16. Next step, keep going, Jamie.
I would divide both sides by 2.
Divide both sides by 2. What am I doing when I'm when I divide both sides by 2? What am I using? Yes.
You're isolating the variable.
What property am I using? If I do something the same to each side, no. Property of equality. And what I'm really doing here is multiplication property of equality. Because isn't that the same thing as multiplying everything by a half?
Yeah.
So multiplication, when we see division or multiplication, it's the multiplication property of equality. Okay? And then we are left with x is less than 8. So as I make my number line, it says to graph, I have 2 numbers that I need on here. What are they?
0 and 8.
Good. And I start at?
8.
And it's a open or solid circle.
Open.
And what direction am I going?
Left.
Good. Your graph should look like this. Okay, what property of equality am I using here? Doing the same thing. What operation is it? Addition property of equality. Does that make sense? Addition and subtraction really could be considered the addition property of equality because I'm adding a negative number. And multiplication and division could both be considered multiplication property of equality. Does that make sense to you guys? All right, so let's keep going and let's try a few. Okay, we're going to use the Sage and the Scribe right now. I'm going to pause this. If you're doing this at home, you can pause the recording and do number 1. Try number 1 and 2 on your own. All right, now check your work. And make sure that you are that you're graphing as well. That's half the points. Next, pause the recording and try the next 2 on your own. Now let's check our work. On number 3, it should look like this. Again, remember, you had to flip the inequality because we multiplied or divided by -1 on both sides. Now, I want to talk about number 4. There were 2 different ways to do it. How many people distributed first? So we can distribute and then divide by. But we also could have done this. Okay, if I have 3, I'll do it here. 3 times x minus 5 is less than or equal to 12. I could have divided both sides by 3. Right away, I noticed that 12 was divisible by 3. So I can divide there. I'm left with x minus 5 is less than or equal to 4. Add 5. X is less than or equal to 9. Did anybody do it that way? Everybody distributed? Okay. Well, it's just a way. Every time I'm using my properties. So here I used the multiplication property of equality. By dividing by 3, I'm really multiplying by a third. Here I'm using addition property of equality. Okay, over here, I'm using the distributive property. Then I'm using the addition property of equality, and then the multiplication property of equality. So as long as I'm using my properties, it doesn't matter which method I use. Does that make sense? All right. Let's try 2 more. Go. This time you're doing them independently. Go. Pause the recording.
So I divided by -3 on both sides.
Good. What am I left with?
I got x minus 4 is greater than, it's less than 3.
Positive 3, good.
And then I added 4 to both sides.
And,
And I got x is less than 7.
okay. And we're graphing. It's open circle and it goes that way. Okay. Actually, how about if somebody does this for me? Let's see. I'm going to go with Jamie right now. Here. Okay. This is the pen. That's the eraser. Okay? But you got to talk your way through it.
Okay, so I would add 2x to both sides to get rid of the negative x right here. So it would be 6x minus 3 is greater than or equal to 11. Then I would add 3 to both sides using the addition property of equality and get 6x is greater than or equal to 14. I would divide both sides by 6 to isolate the... It's the multiplication property of equality, or the division property of equality. And now that the variable is isolated, it would be x is greater than or equal to 14 over...
But we always like our fractions.
Simplified, so it would be x is greater than or equal to 7 over 3. And then we have our number line with 0 and 7 over 3. It would be a solid circle because we have the equal to sign right there. And it would be going to the right.
What does that mean, that solid circle, guys? What does that mean, Gracie?
It means that it includes the number where the second line starts.
Beautiful. And I love how he used, when he was explaining it, his properties of equality. All right, so now let's go on to, let's hope we get to our word problems. Beautifully done. Remind me you guys want to use the iPad tomorrow, okay? All right, Joe is saving for a new bike, a $500 bike, and he currently has $125. If he saves $15 per week, how long must he wait to save at least $600 to cover tax and extras? So step 1, we always identify what's unknown. What is my x? Give me a definition for it. Mike.
How many weeks?
How many weeks? Good. So we're going to say x stands for weeks. And generally the pattern is, in a lot of multi-step equations, we have a base. Can we just finish? Who knows what the equation is? A base plus we're adding something per a number. So what would it look like, Gracie?
It would be 125 plus 15x
Is at least what?
greater than or equal to 600.
600. What piece of information is irrelevant here?
The $500 bike.
The $500 bike. So we're subtracting 125 and we divide by 15. And now this is very important with inequality word problems. Everybody pay close attention. I know that bell rang and you're out the door in your head, but make sense of that ending. What does that mean, Elise? X is greater than or equal to 31 2/3 in relation to the story.
I think doesn't mean he has to wait 31 2/3.
Well, but if I get paid per week, if I save per week, how would I do that? Elise, do you want to rephrase that? Okay, Noah?
He has to wait 32 weeks.
32 weeks. You've got to make sense of this and go to the closest, like, integer. Does that make sense? You're going to 32 weeks. And we'll stop there, and we'll finish this next word problem tomorrow.
Sounds like you can finish correcting the